Or two for everyone to trickle in, but this talk is how to make nearly anything really fast. And this is not about making fast things, it's about making things in a fast manner. But if you like talking about fast things, then I like race cars and spaceships, so we should hang out at some point this weekend. So this talk is essentially going to be me rambling about stuff that myself and my friends have made in various maker spaces, most notably the Invention Studio at Georgia Tech, but I've got a bunch of friends that go to MIT, and there are resources there like MITRES, and they've started, I was interested in robotics in high school, and when I got to college at Georgia Tech as a computer science major, I started hanging out around this machine shop and realized that I like making things with my hands a lot too. So they kind of got me involved in BattleBots in the past 2 years. But I also do some research, and most of my research is in physically prototyping things. So I'm going to essentially talk about how to make really anything you want in a cheap and efficient manner, using tools that are now really accessible to just about anyone. And before I really get into it, I have a QR code, so if you want to follow along, you can just download the slides right here. So yeah, there's that. I've got a bunch of links and stuff. Essentially, the format of the talk is going to be about some techniques of constructing things that make constructing things that are three-dimensional or very complicated a lot easier, and how to essentially resolve very difficult to make things into very easy to make things. So like taking a complicated three-dimensional part and then taking that down to the point where you can use a bandsaw and a drill press to make it, versus like a 3-axis CNC mill or things like that. I meant to bring in one of my 3D printed helmets. It's in the car, I'll grab it later. But yeah, so we'll talk about that a little bit. We'll talk about some softwares and resources for, like, if you want to design something in CAD, or if you want to design a circuit board, or if you want to get a circuit board made by a board house, where do you go to do that? Where to buy electronics parts, where to buy motor controllers and robot parts, and then talk a little bit about machines like 3D printers and CNC routers and soldering irons, and if you're wanting to get started in making things, where do you go and what do you buy to really get started, and what are the things that I really like to use and what are the things that I don't really like to use. So yeah, everyone good with the QR code? Cool, thanks. We'll get started. My name's Chad. I'm a CS undergrad at Georgia Tech, like I said. I'm doing a victory lap right now, which is 5th year. I've been around tech for a little while, but it's been a good time so far. I've done a bunch of internships because I like having some real-world experience. And that's one of the reasons why I like making things, is because we learn so many things in class that are great in a textbook, but I like actually doing things with them because I'm a pretty tactile learner. So making things is really the way that I learn. I see something complicated and I want to do something with it, and that's how I learn. I like writing Python a lot. It's really fun, and I think I'm pretty decent at it. I also like music and building things. Some of my research interests have been in AI and machine learning. I'm into nuclear engineering, and breakfast is my favorite meal. So before we get into how I think you should make things, I just wanted to give you a little bit of information about things I've made before, so you can get a little bit of my perspective and how I think about making things. My sort of first really big project happened in high school when I was really bored with what I was learning in physics and chemistry, and I had this kind of quarter-life crisis, and I decided that I wanted to do something that no one had really done before. I wanted to do a real science experiment, something that I knew had never been published before. And at the time, I was kind of into renewable energy. I still am now. I think fusion is really, really awesome. And I found out via Popular Science magazine that people were building nuclear fusion reactors in their garages and basements. And I said, maybe I should try to do that. Because who wouldn't if you knew that you could build a nuclear reactor in your basement? I mean, that sounds like a totally legitimate thing that any normal person would do. So I went for it. Fortunately, just about anything these days is represented by a community on the internet, and building nuclear reactors in your garage is no exception. There's this awesome website called fuser.net, and it's a bunch of physics nerds and engineering people who like to build high-energy physics experiments in their garages. And so this whole system ended up being a vacuum chamber, a high vacuum chamber with a system of vacuum pumps that sucks nearly all of the air out of a chamber. It gets down to very near the pressure of outer space, and then you pump in some deuterium gas, which is an isotope of hydrogen. It's just got a neutron in the nucleus. And then you have like a glorified spark plug on the top of the vacuum chamber that allows you to put in voltage into the chamber. And you simply put 50,000 volts of electricity into the chamber on a little grid in the center, negative potential. And when you do that, you start ionizing nearly everything in the chamber, and you attract everything that's positive once it's ionized to the center. And so you get this little plasma star that you see forming in the center of the chamber here, and everything sort of gets attracted into that. And if you can get enough energy on the things that are attracted into that, aka putting enough voltage in, you get fusion. So you can really create nuclear reactions in your garage, and it's a very, very low amount of radiation, really laughable. You would have to run one of these things for tens of thousands of years and be standing within a foot of it to actually start absorbing enough energy in your tissues to make things like cancers. I mean, of course, there's a risk of cancer at any exposure of radiation. I mean, we're all radioactive. The banana you might have ate for breakfast this morning was certainly radioactive. Everything's radioactive. This is a very, very low amount of radiation. This is like banana level radiation, and no one's running from bananas.
What percentage is actually converted to hydrogen? How many to helium?
So this is it's a 50-50 reaction rate. So on 50% of reactions that happen in this, you get helium-3, and the other percent you get tritium. And on one side you release a neutron, and the other side you release a proton, and you can detect the neutrons. So that's how you know fusion is happening. And right now I tore the whole thing apart, and I'm building a particle accelerator. So that's like my next really big project. And fusion, after you've done it, you kind of look back and you're like, that's a vacuum chamber, and I'm putting a bunch of high voltage in it. It's an exercise in how resourceful you are. And it is almost certainly a very hard engineering challenge as well, but building a particle accelerator makes it look like putting Legos together. So I'm trying to build a cyclotron, which involves making an MRI strength magnetic field and then putting a vacuum chamber in between them and doing all sorts of witchcraft with radio frequency switching potentials. And if you're interested in that, let me know, but that's not the focus of this talk. So moving on, I've done mechanical things too. Very recently I've become interested in battle bots. The bot here on the left is called Atomic Puppy. I unfortunately built this in about a week. I was interning at the time, and the place I was interning had this really nice hackerspace on campus that they would let you use. So I pulled 18-hour days at work for a week, and worked for the allotted time that I was supposed to work, and then spent 10 hours building a robot. And they had this little CNC routing machine that I was able to make all of this out of. It's 3D printed out of ABS, the little clamps and wheels. And then the main body frame is made out of aluminum rods that I ordered from McMaster-Carr, and then the black pieces are high-density polyethylene, which is a super impact-resistant material that's actually really easy to work with, so it's a great candidate for BattleBots. This is a 3-pound BattleBot, and it was pretty fun. It was a good experience. The thing on the right is a little electric go-kart that I made. They're kind of, the MIT crowd builds silly go-karts all the time, and they call them chibi carts. And this is a southern fried chibi because we built it at Georgia Tech, and we're in the South, and MIT's not in the South. But so southern fried, and this is some child at Atlanta Maker Faire that was riding it, holding a laser cut banjo. It was pretty fun. So it's got 3-phase brushless motors, similar to what Tesla uses in their like Model S's, but on a much smaller scale. And lithium polymer batteries, so you get into all sorts of really fun technologies that are being used in large-scale electric vehicles on a smaller scale. And once you sort of get familiar with this electric vehicle workflow, you kind of, it's like an addiction. You want to put like a motor on everything, because you can go buy a 3-phase brushless motor that's like 1.5 horsepower for about $100, and then you buy a controller for like $50, and then some batteries for $60, and you know, for about $300 altogether, you have like a really silly electric scooter or small bike or something like that that you can ride around campus, and it's pretty hilarious. And the torque that these things have are just scary. I built an electric longboard over the summer, and originally it was rear-wheel drive, but the way the motor's torqued, it would torque the board up. So you could throw yourself off the board with how much torque the motors had. So we had to turn it around and make it front-wheel drive so it torqued down instead of up and didn't throw you off. So always build brakes into your electric vehicle. Lesson learned the hard way there. Some things you just don't want to prototype rapidly. Brakes, one of those things. So rapid prototyping in general is this terminology that's sort of developed over maybe like the last 20 or 30 years as electronics and mechanical and linear motion components have become more ubiquitous and really cheap, which have unveiled a new way of using computers to make the entire prototyping process quicker. Since we have smart machines now that allow to really hard tasks to become super easy, like 3D printing something, you can spend most of your time focusing on designing the actual part and then using the computer smart tool to sort of do the rest. This was a totally new school of thought for me, coming from high school doing robotics, where we would take plywood. We did this competition called Best, where we would get like a big box full of parts, and then we had to make a robot over 6 weeks with it. And we kind of just shot from the hip, and we would take plywood and send it through a bandsaw and cut pieces off until we had something that looked like a robot. Then I got to Georgia Tech and met a lot of people who were sitting down on their computer for like 2 weeks designing a model in a CAD software like SolidWorks, which allows you to do 3-dimensional parametric drawing. So you can build your entire thing in the computer, put it together as an assembly, mock up the bolts and screws and see how everything's going to fit together, put your motors in, do stress analysis on how all the parts are going to move around. They would spend maybe 80% of the time doing this on the computer, press a button, have their materials list generated for them, send that to MasterCar and an electronic supply warehouse, get all the packages back, and then build the robot in a day, because all of the hard stuff, the design, was already done. They would send it to a water jet or a laser cutter, and then you have a bunch of parts that slot together, and you have a robot in a day of actual machine. So. And this is a valid way to make real things, because you can make things like BattleBots, which are just going to have, tested to the limits of what materials and electronics can be used for, stand this test of going to competition after competition, even though they're built in like a day or two. So I was kind of obsessed with how this can happen, and how regular people like you or I can use this to our advantage to make anything we want. So I kind of took the Wikipedia definition and changed it a little bit to my liking. But essentially, these technologies that we end up using are either like a CNC, which is computer numerically controlled, things like CNC mills, lathes, and routers. CNC mill is like a really fancy drill press that can move in a couple of different axes. Lathes are things that make parts that are concentric about, so essentially like cylinders and bolts and screws and stuff like that are what lathes are good for, and routers are mainly used for 2-dimensional parts, so like flat parts you can cut out with a router. It's basically a cutting tool. Water jets, if you ever have the opportunity, if someone like lets you know, like, this place has a water, you could work here, this place has a water jet that you could use, or you could go to this university and they have a water jet that they let their students use. Georgia Tech does, which is awesome. Do that thing so you can use their water jet. The coolest tool ever, and it will spoil you. My parents speculate sometimes that the reason why I've taken 5 years to graduate from undergrad at Georgia Tech is because I can use a water jet for free all the time. I have 24/7 access, and it's essentially this machine that takes a high pressure stream of water at like 60,000 psi and can cut through just about anything like it's butter. So we can cut through up to 6-inch thick steel. You just give it a 2-dimensional design file and press go, put your metal in, and then it uses water to cut out your parts.
Is there a minimum number of hours you have to take, or can you just take one class and have access?
Yeah, you can take one class. So the deal at the Georgia Tech Invention Studio, it's this really neat place. It's a student-run hackerspace at Georgia Tech, and we have this program. After you've demonstrated your ability to use all of the machines in the space, you can volunteer and you give 3 hours of your time a week to come in and help other students make their parts, and then you get 24/7 keycard access. So about 90% of my free time at Georgia Tech is spent in the Invention Studio, and it's this amazing crowd of interdisciplinary people. So I would certainly say, if you've got a hackerspace wherever you live, it's worth getting involved in. I have that in my resources section. Atlanta has Freeside, and it's a really awesome place of totally epic people. Being involved in the Invention Studio at Georgia Tech has changed my life for the better, and I would definitely recommend looking into your local hackerspace if you have one. Water jets are, sort of uncommon to come across as being able to access them all the time, but there are tools now like Big Blue Saw, and you can send them your files and what metal you want it to be cut out of, and then in like a week they'll send you back water jetted parts, and it's a pretty cheap rate of actually getting them cut out. And they handle like all of the running the machine and getting the metal and stuff for you. So it's a really great service. Laser cutters and 3D printers are almost dirt cheap now. They're starting to get to the point where the laser cutters and 3D printers are very minimally priced, more than the parts that actually constitute them. And you can make those yourself pretty easily using like hand tools and a drill press and a bandsaw. So oftentimes at like solo level makers, rapidist prototyping often involves like 3D printers or taking three-dimensional parts and breaking them into two-dimensional parts like I was talking about earlier. So the first technique I'll cover is called finger joints or T-slots. If you've ever done any woodworking, finger joints will probably sound familiar with you. This is basically a way of taking like, let's say we were wanting to make a box. We could take this box, divide it into sheets, and then generate a pattern of slots that fit together like your fingers fit together with each other. This is really neat because you can add fasteners in and end up getting a really rigid structure. This go-kart that I made, the picture is kind of terrible resolution. Well, it's not terrible resolution, but it's small compared to how you can see, if that makes any sense whatsoever. There are gussets on this frame that's bolt into this aluminum extrusion that I'm using that take advantage of this T-slot structure. So you can insert fasteners in and end up getting a really sturdy part out of like acrylic or wood. These designs are pretty common for like laser cutting things. If you need to make, like I said, a box or a simple frame, this is a really handy technique. And there are lots of online tools now that will generate this for you. There's a website called makercase.com, and you can give it the size of the box you want and what hardware you want to use, and it will generate a PDF, an SVG, or a DXF file for you, which you can go and then like trace onto wood and cut it out by hand, or send it to your laser cutter, and then cut out your box, slot it all together, and then you've got a finished thing. So project enclosures for like guitar pedals or your pirate box become a matter of like a 10 or to 20 minute job if you've got like a laser cutter, which again is decently cheap these days. One of my favorite techniques that I think is kind of underutilized right now is actually, I've mentioned this several times, you can tell how much I like it, is taking a 3D object and breaking it into 2D slices. So Lexus just recently published a video where they hired this art studio to make one of their cars out of cardboard. And they took a three-dimensional design of the entire car and then used this software called 123D Make. And it goes through, you tell it the size of the material stock that you want to use and how you want it to slice. So 123D Make can do like these puzzles you maybe had when you were a kid where you have pieces and then they're slotted so that they fit together, like finger joints essentially. But it can also just do slots that, or slices that just sit next to each other. So you can glue it together or use a dowel or fasteners through the entire length of the part. So with the Lexus car, let's do some Googling here. Access cardboard. They actually drove it, which was crazy. And they actually have a video in which you can see them using, I meant to view image there, I'm sorry. Okay, so here you can see that they've stacked slices to form the entire body of the car. So you can, using this technique, you can envision making just about any shape you want. And the really neat thing about this is the software 123D Make will generate files for you that you can like print out on a plotter or trace by hand onto any material. And then you can basically make any shape you want using a bandsaw, which is a tool that you can get for like $100 off of Amazon and ship it to your house like today. And that's a really empowering thought to me. You could make this out of MDF or plywood and then sand it and have really smooth edges. Freeside just recently has been doing a cosplay meetup, and they were doing some really fancy three-dimensional sculptures, and they did a slotted together part kind of like the T-Rex that I had up earlier. A three-dimensional part like this, but they actually wanted it to be filled in so it was a smooth surface on the outside. So they made a structure like this and then filled it with expanding foam spray and then sanded it. So it really depends on the structural quality that you need, but if you have a 3D design, you could make it out of cardboard that you cut by hand with an X-Acto knife even, fill it up with expanding foam, sand it down, and then you have a really complicated part that would have been, you know, hard to sculpt by hand, but pretty easy to do this way. There's a prop guy from Atlanta called Vulcan Props. If any of you go to DragonCon, he's the guy that did the Marriott carpet, camo. He made some Daft Punk helmets a couple of years ago that he got sort of internet famous for, and one of the ways that he made the helmets from scratch, I have massive respect for the guy. If you've never seen his website, look up Vulcan Props. It's a fantastic resource for anyone who wants to make things. His Thomas Daft Punk helmet, which is the one with the visor going this way, if you're familiar with Daft Punk, he made it with this technique, filled it up with foam, and then sanded it down till he liked it, and then bonded on top of it and cast it from there. So this is a really diverse method of making very intricate shapes that you might want to use for cosplay or those sorts of fun things, or even cars for Lexus.
Make them better, faster, and stronger.
Yeah. So I mean, once you have something in the real world, you can like cast it with epoxy and make a plastic part, or put it into a sand mold and then cast it in metal and things like that. The last technique that I really wanted to emphasize today was just 3D printing it. And I have a sad face here because at Georgia Tech, in the Invention Studio in particular, there have been a lot of mechanical engineering students, sorry if there are any Georgia Tech mechanical engineering people in the crowd, who have learned that they can just 3D print things. This is not really an acceptable technology for building structural parts. There are 3D printers now that can incorporate Kevlar or carbon fiber. The 1 pound BattleBot at DragonCon competition this year had a Kevlar 3D printed robot in it, and it actually ended up winning, I believe, or it was in the top 3. So 3D printed parts are beginning to be structurally usable. But 3D printing is becoming like a magic box for engineers, where they can design something on the computer, press a button, and then a part comes out on the other side. And it doesn't really require as much forethought or analysis to make your part anymore as it would if you were taking it to a laser cutter or a water jet, where you actually have to think, how is my part going to fit together, and how is it going to stress and bend and warp after I put it together and put a load on it. So this is really good for making things like I 3D printed a Master Chief helmet from the video game Halo, and I'll bring it out later. And parts like that are really, really great because they would be a total pain to sculpt by hand. And doing it by cardboard, you would have such a low, essentially low poly. You have a very low resolution with a material that's 1/4 of an inch thick when you're trying to get features that might be, less than 1/4 of an inch thick. So sometimes 3D printing is the best answer, and 3D printers are starting to get really, really cheap now. You can get like the PrintBot basic metal for like $300. You can build like the Persa i5 bots for about that same price range. And then the bots that I actually recommend, which we'll talk about in just a second, are in like the $500 range. But these are 3D printers that we've tried and tested at the Invention Studio, and they work phenomenally well. And there are a lot of people now who are making new techniques to take 3D printed parts and do really, really intense things with them. Like, for instance, they're building an entire canal house in Amsterdam with FDM-style 3D printing. So this particular 3D printing... Yeah. So FDM? FDM stands for Fused Deposition Modeling, which means that 3D printers like this one here, I didn't have time to set it up before the talk, but I'm going to set it up out there. So if you've never seen a 3D printer running before, let me know and I'll like print you a bottle opener or something, because they only take like 5 minutes. I'll have this guy running out there. But essentially the way this whole process works is FDM printers are essentially a fancy hot glue gun. You have a heated nozzle that you feed plastic through, and when it goes through the heated nozzle, it melts, and then you just move that nozzle around in the pattern that you want to create in the real world. So you take any 3D model you want, slice it into your layer thickness. For instance, this prints in 100 micron thick layers, so think about the thickness of a sheet of paper. You have a piece of software that goes through that part, divides it into 100 micron layers, and then at each of those parts, it does an algorithm that finds the path around that, and then a path through that to make a fill structure on the inside. So most 3D printed parts from FDM printers are not actually 100% solid. You print them with an infill, so like a honeycomb structure on the inside that lends structural integrity, but does not require a whole lot of time or filament to actually build the whole part because it's not solid throughout. So it saves material. And so you do that, and then it goes to the next layer. And the printing process works by doing those layers one at a time, and then in between those layers, the platform moves down or the head moves up, and then does the next layer and proceeds until you have a full object. The reason why I have a sad face here in addition is because printers have, the nicest way of saying this is printers have improved a lot over the past 5 years. 5 years ago, they were really agitating to have to deal with, and for a while I worked in the Invention Studio as the 3D printer person. So if a 3D printer broke, I was the one who fixed it. And if you do that with any technology, I'm sure the IT folks in the crowd among us will know if, you might take something that you love, and then if you have to fix it all the time because someone else broke it, you're not going to like it after a while. When they work, though, they can be your greatest friend. It's a really cool experience to be able to like need something, have an idea in your head, design it, and then press a button, and then have it print while you're sleeping, and then wake up in the morning and have like your physical part. So that's a pretty cool experience that I like. If you have just some money that's burning a hole in your pocket, I would recommend buying one because they're pretty fun. As far as software goes, I think one of the best things that anyone who wants to make things can do for themselves is to pick up a CAD package, which is computer-aided drafting, and get familiar with it and start using it to design things. So working with CAD really teaches you a lot about the process of designing something for the real world and how things should fit together and where bolts should go and your size and weight constraints, and things like battle bots and spaceships and race cars all start typically right here. After you decide that you want to make it and you have a rough idea what it's going to look like, this is your actual drawing block now. Especially with digital manufacturing technologies. This particular CAD package, which is pictured here, is called SolidWorks. SolidWorks is pretty nice. It's kind of an industry standard at the moment, but it's decently expensive. It can be acquired, of course, through the internet for less than its retail price. So if that's your thing, go for it. They're a very big company, and the company that owns them, Dassault Systems, spawned this 3D printer company. This is a rant, but spawned this 3D printer company called Stratasys, who owns MakerBot. and they make really terrible printers now. So if you go and you get their software for less than retail price, don't feel bad about it because they're kind of a terrible company. There are companies like Autodesk, on the other hand, who make softwares like Autodesk Inventor, and if you have a .edu email address, they'll give it to you for free, which is awesome. They also have many versions of their products that are just free. Yeah.
Solid Edge.
Yes, there's also Solid Edge, Pro Engineer / Creo. This is what NASA uses for most of their stuff. It's also pretty similar to SolidWorks and Autodesk, and it can you can find like trial versions of that are used for non-commercial version of things that you want to make. And last time I checked, I think that was free, but I'm not sure. Yeah.
If you're a programmer, OpenSCAD.
Yeah. So OpenSCAD is great. I've seen it kind of widely adopted in the 3D printing sphere, and there are really great tutorials for that. And if you've never gotten started with CAD, the thing that I really like about SolidWorks, because Georgia Tech gives all of their students a license, I'm going to have to figure out what I'm going to do when I graduate because I won't have it anymore. But they have a really nice suite of tutorials that they've actually published on YouTube now. So if you end up getting a copy of SolidWorks, they have tutorials that will take you from no CAD knowledge at all to making really, really complicated parts. As for electrical design goes, there are softwares like KiCad, which run in Linux. It's a free open source CAD software for designing circuits. It also has a huge community around it. You can basically go from having nothing to building a full circuit board in KiCad from bottom up, which is really, really, really neat. You can build like 4-layer boards with ball grid array chips and make really fancy stuff in KiCad. And Eagle is kind of its industrial brother, I guess. Eagle is really nice because they give you a free version of their software that will do up to 4-inch by 4-inch boards. And this is a pretty industry standard software. Altium is another electrical CAD software that is very, very expensive, and I personally think Eagle and KiCad can do most of, as far as circuit design is concerned, can sort of compete with Altium decently well. Altium does some neat testing things, but if you wanted to go and design a circuit board today, you could pick up KiCad or Eagle and actually do it. The thing that's also nice about Eagle is SparkFun has a series of really, really great tutorials where they will take you from zero circuit design knowledge at all to how to design. I think they have a tutorial on an FTDI programmer chip, so you make a circuit board that allows you to do USB to serial for like programming microcontrollers and stuff like that. So they teach you to make interesting stuff, and they have like their own library of parts that you can use. So SparkFun is really, really nice to the community with their tutorials. If you've never checked those out before, definitely do that as well. 123D Make is made by Autodesk. Like I said, it's a super, super handy thing, especially if you don't have a laser cutter or water jet, fancy tools like that. 123D Make, I mean, you can take any 3D object, slice it in, and then make it with a bandsaw and a drill press. Then as far as CNC machining goes, I figured there wasn't going to be too much of a crowd that was interested in like CNC milling. But the thing with, once you get into like CNC milling, you have to have a step between your actual CAD and the machine itself. You have to program it into the language that the machine speaks for how it should move.
The G code.
Yeah, the G code, the code for the G's. For that, you need computer-aided manufacturing. Yeah.
Is that because different CNCs have a different number of axes?
Yeah.
For that number of axes?
Yeah. So each machine or each brand has its own like standard for how it talks and how it references particular tools and how its accelerations work while it's machining on a certain axis and how many axes it has. The list goes on and on and on. So you need something in between that you tell the machine like how the tool is operating, how it should move, how fast it goes, and things like that. For SolidWorks, I use a program called HSMWorks, and it's really, really awesome because you can design a 3D part and then bring it into HSMWorks and actually watch a virtualization of your CNC machining process in the software. So you can be like, I want to cut this shape with a 1/4 inch end mill spinning at 1000 RPMs from this block of HDPE that's an inch thick. And it will actually go through and you can watch it do its thing and get an idea of what the actual machine is going to do. HSMWorks is now owned by Autodesk, and you can plug it into Inventor or SolidWorks, and they have a version of this for 2-dimensional CAM. So if you have like a CNC router or you've built a CNC router, you can get HSMWorks, and they will allow you to do 2-axis cutting for free, which is a really, really awesome tool. I mean, this is industry standard, and everyone is, it's super awesome. So as far as like construction technologies go, if you're wanting to make mechanical things that you can like sit on and ride, 80/20 is really, really awesome. If you've never played with 80/20, I'd recommend going to McMaster and buying some and just having fun with it. It's kind of like a fancy grown-up Rector set. I call it Legos for mechanical engineers because it's this T-slotted aluminum extrusion, so you can slide nuts or bolts into it and then you fasten things to it. So like these chibi carts, this is one of the MIT chibi carts. Everything here, they've made some flanges out of aluminum and then just bolted into the frame. So you can like slide a nut into the frame, and then it's captive because it's a T-slot. So you have these 2 pieces of aluminum that once you slide things into them, they don't pull out. So you can slide them linearly, but not in the other axis. So you can bolt things to this and build really neat things. This is called 80/20 because they say it's like 80% of the strength of a regular like solid aluminum extrusion of the same dimensions at 20% of the weight. So it's also really lightweight. And it does 80% of the work in 20% less time, I think, is their other like saying from the company. But McMaster Carr sells their own version of it called T-slotted aluminum extrusion. That's much, much cheaper than the like copyrighted version from 80/20. And this is good for making things that you can like stand on or ride. And so one of my like last talking about making slides is about making things smart. This is something that Apple and Google and like all of the, and Microsoft, all the really bigwigs people are starting to do with our smartphones and things that we're wearing, doing gesture recognition and activity recognition. It's something that I started to play around with a little bit. So if you're wanting to build something that you can use to control your lights by moving your hand about or things like that, doing gesture recognition is really, really, really neat. It's a way of taking some numbers or sensor inputs and translating those using a pattern recognition or machine learning model into classification as a particular swipe or something like that. And there are 2 really, really nice tools right now to do this with. One is called the Gesture Recognition Toolkit. And with GRT, you can actually take an Arduino, pipe some data into it, and train various machine learning models, and then tell them classify the data that I give you next, and it will make usually like a Bayesian model or a decision tree model that you can use to predict, you know, if I made a G in the air and did that, you know, 100 times or whatever, trained the model and then did a G again, it would hopefully tell me you just made a G in the air versus an L or something like that. And then you can translate those inputs into like turning a light on and off or things of that nature. And something that I've played around with very recently is called Clarify. It's a deep learning image recognition API that allows you to use, they have these binary classifiers, so things that you can train to say yes or no, like this is a L or this is a G or it's not an L or a G. And my friend and I built this little lightsaber over the course of a weekend. We 3D printed the lightsaber and put an Arduino and an IMU on the inside of a lightsaber, and we wanted to try and see if we could use Clarify to classify time series data. So their API is actually made for like recognizing things and images. Like you give it an image of a cat and it says this is a cat, or these are a bunch of happy people or sad people. They were not doing any time series recognition, so I was like, I want to see if they can classify this. So what we did was we took the accelerometer data, fed it into a complementary filter. So we took the X gyro value, the X accelerometer value, added them together, took the Y accelerometer value and the Y gyro value, added them together, and then just used a Python script to plot them in Matplotlib. And we noticed that when we did swipes, we did left, right, up, and down. We are building a demo using Imgur, so you can like swipe, wave the lightsaber around and swipe back and forth images on Imgur and then upvote and downvote accordingly. So we did left, right, up, and down. We made these plots and we realized that each of those swipes are unique in their plots. So every left swipe had this pattern where you had like the blue line going up and down and the red line going down and then up. So you have like a diamond shape here. And then if you did an up, it was a distinctly different pattern. So what we hoped is that we could construct a set of these models and then feed them into the binary classifiers and then give it data in real time and then it tell us if this is a left, right, up, or down. And it's actually able to do this. And this is like 20 lines of Python that you need to go from sensor input from an Arduino, doing like very minimal filtering, plotting on Matplotlib, and then training and calling their binary classifier APIs. So it's like as far as writing the code goes, we spent like 2 hours doing that. Most of the weekend was spent trying to get a ESP8266 module, a little Wi-Fi guy to talk to another Wi-Fi guy. We never made it work, but this did work, and we were getting really, really good recognition rates. We had like over an 80% recognition rate for all of our swipes with a training set that was only like 50 images large. So if you ever want to play with neural nets and deep learning for neat stuff, their API is super awesome to play around with. As far as materials, I just threw in like everywhere that I buy stuff from is kind of in this slide. If you've never been to McMasterCar.com, go there like now. You can get anything you want from McMaster. They sell like weird alloys of titanium or stainless steel in sheet, rod, ball, or extrusion form, fasteners, doors, ventilation systems, drill bits, machines, motors, everything. It's a really, really awesome place, and they ship super fast. Sometimes they're more expensive than other places, but if you need like a sheet of 6061 aluminum that's a 1/4 of an inch thick that's a foot by a foot, and you need it tomorrow, McMaster is where you go, because they have it. Mouser and DigiKey are really great places for buying like raw electronics. So if you want to buy like 100 Atmega 32U4s, Mouser and DigiKey are there to oblige. Now, if you want that Atmel 32U4 on a dev board that you can like stick a USB stick into, or a USB cord into, and then program right away, SparkFun and Adafruit, probably most of you are aware of these already, but sell really nice development kits for all sorts of electronics and mechatronics components. Both of those actually have really, really good tutorial databases, so you can learn a ton on these sites. They're really, really great resources to the maker community. In Atlanta, we have a couple of scrapyards. Sometimes they have really fun things, and I would encourage you to find one around here or wherever you live, because you can typically get really great things and good inspiration for projects from your scrapyards. It's amazing what you can buy on Craigslist and eBay. I'll leave it at that. And then the last two sites, Hobby King and eLifeBike, are like my favorite two Chinese websites. They sell really cheap like 3-phase brushless motors and lithium polymer batteries and 3-phase brushless motor controllers. And Hobby King actually sells a lot of RC stuff, but eLifeBikes is a hilarious website that sells like electric bike components from China, and their website is pretty hilariously translated, so just reading through the website is really funny. But a ton of my friends and I have ordered stuff from the site, and we always get it, so it's pretty reliable, I would say. I don't know if they're like storing all of my information somewhere. Probably are, but I get my parts, so I'm happy. I have a couple of slides here for machinery and tools that I recommend. If you have any specific questions on like if you're considering buying a 3D printer or a soldering iron, ask me, and I'd be happy to give you my recommendations. These are things that I work with like every day when I'm building stuff. So I like to think that I've had over a period of time a large database of, or set of experiences and information to make suggestions about what you should buy and what you shouldn't buy. If you're just interested in getting started in 3D printing, then the Up Mini is like a fantastic 3D printer. They're $600 on Amazon right now, and they go like crazy. You can send them parts 24/7, and they almost never break. The same cannot be said for this guy, which is made by the evil corporation that I was mentioning earlier. He was actually being thrown away, and I rescued him, but he's still a pain sometimes. You can also, once you have a 3D printer, you can print other tools like CNC routers. There are now almost entirely 3D printable CNC routers, and then you can use that to make even more serious tools. So you make a 3D printed CNC router, and you cut wood with that to make a wood CNC router, and then you cut aluminum with your wood CNC router, and then you actually have a nice machine.
What an time to be alive.
What an exciting time to be alive, exactly. You are the man. And then you just burn your 3D printed in wood one.
What's the best dual element, affordable 3D printer that you've seen
So there
that doesn't break?
is, yeah.
Doesn't exist.
Often.
Next.
Often.
Um,
Road stock knife.
There is a Chinese knockoff of the MakerBots called the Flash Forges, and you can buy their dual extrusion version for like $800. And I think that's like, it's going to break sometimes, but that's like the best price point that you can get it at. And there was a startup that did a Kickstarter for an extruder that actually took in 2 colors of filament and then could swap between them. And I've heard really, really good things about them. Unfortunately, not enough good things for me to remember their name, but you could probably look them up on Kickstarter. They were pretty neat. There's also a startup right now that is making this box that has an extruder on the inside of it, and you feed it in multiple colors of filament. You send it your sliced multicolor file, and then it extrudes a single filament that has multicolor sections in it, and then it's synced so that when it prints, it's the right color. And that's pretty neat, but they're wanting to charge like $2,200 for it, and that's way too expensive. Yeah, any more questions?
2 questions.
Okay, go for it.
Questions now. I was
Yeah.
trying to hold back.
That's fine.
You're talking about your 3D printed Master Chief helmet.
Yeah.
I saw another program that somebody had been using where you could take your regular printer and you do a 3D model, and it would take the polygons from the model, print them out on paper.
Yeah,
and
yeah.
it would number the edges so you could
Yeah.
tape them together and then spray them with an acrylic and have a plastic part that you had made from paper.
Yeah, Pepakura.
That's it.
Yeah,
That's what
it's
we were
like
talking about yesterday.
hugely adopted in the cosplay community, and I don't use it because I'm really lazy. But you can actually laser cut Pepakura files too, and I'm really bad at folding things and cutting things in straight lines. But yeah, it's awesome. I'm wanting to make the rest of my rest of Master Chief's armor, and I'm probably going to do it out of EVA foam with the Pepakura files. But it's super, super neat. Yeah.
There's another 3D printer I saw just the other day. It's the unit, the printer, it doesn't print very large items.
Yeah.
But each one is about the size of like a 20 ounce or a 1 liter Coke. And it uses a regular projector like the one you're using right now
Yeah,
for demonstration to
DLP.
cure everything.
Yeah.
And it brings it from overhead, so you can actually have 3 different pieces put together, and the elevator just takes it down while it cures with a regular.
Yeah, so that's a SLA, which is stereolithography. So you have a photopolymer resin and then a source of light that is of the wavelength that cures that photopolymer resin. So you project a light onto that and then it cures. And those are starting to get really, really cheap too. There are some that are sub $100, but the photopolymer resins are really, really nasty chemicals sometimes, and oftentimes those will degrade over time. But it really depends what you're looking for in a printer, and sometimes that's all you need. Yeah. Anything else?
You experience with the like $300-$400 laser cutters that I see on eBay?
No, but I've wanted to buy one, and probably when I graduate, I'm going to.
You buy one first, okay?
So I've been to several hackerspaces that have like the really cheap eBay. RxTX in Houston, Texas had a really cheap one that I used. I don't know if it was that cheap, but all of the drivers and software for it were super sketchy. But as far as the laser itself goes, I mean, glass CO2 laser tubes are pretty standard technology, and all the linear motion components are there too. I mean, if you look at pictures and it looks like it has stepper motors and Acme threads and things like that, you can write your own drivers and softwares for it or use someone else's pretty easily. So as long as it has a decent laser tube by it, it's probably a good thing to buy. But the Freeside guys have a decently cheapish laser that they could probably get.
We made ours for like $1,600. It was off of Chinese. No, it wasn't. It was off of a website that we had that had like source stuff. Anyway, fly-by optic system. It uses a couple of mirrors to aim where the laser goes. You can actually do DIY laser mirrors off of hard drive reader heads, and they're reflectable. Just don't touch them, basically. And then it's just a carriage motor. So, and you can actually use 80. We use 80/20 for ours for our mirrors.
So you can make the frame out of 80/20. You can make CNC router frames out of 80/20. It's a really great stuff. Yeah. Any more questions? Yeah.
Are you a wizard?
No.
Warlock?
Maybe.
Jedi.
I'll consider myself a wizard when I figure out RF power systems. Because that's
pretty cool.
that's magic. That's magic. So once I get the cyclotron built, then maybe I'll like put wizard on my business cards.
I'll put it on your business card.
Thank you. So thanks everyone for coming. I think we're out of time. I'll be around all weekend. If you want me to 3D print something for you, let me know. I'll have it set out somewhere over here. If you want to talk about making things or race cars or spaceships, I'm your guy. Nice to meet you. I'm Chad. Thanks for coming.